today we have Hector Nieves, and he'll be discussing with us some recent advancements and developments in our Powerbox film capacitor capability. Hector, please.
Thank you, Wilmer. Can you hear me?
Yes.
Great. Good morning, good afternoon, and good evening to all of you. Thank you so much for your time, and thank you for your participation. Again, please, we're going to review this latest developments from the film group of KEMET about two particular capacitors, what we call the C4AF and the C4AQ capacitor. One is a DC-Link, one is an AC filter, and I want to see some of the advancements of these technologies for your designs. We'll make some examples of design simulations and design calculations for you, so you can understand how easy it is to select these technologies. This is an overview of how the agenda is going to look for the presentation, and then I will first to introduce myself. My name is Hector Nieves. I'm a product manager with the KEMET Film Capacitor Business Group. Our headquarters for the Film Capacitor KEMET Business Group is in Italy, Bologna. I've been with KEMET for 11 years, and I've been doing from the beginning capacitor application in the field, and then I passed to the Film Capacitor Group as a product manager for OEM business development in America. So now I am more concentrating my efforts on the marketing aspect with the R&D team, with the product management team, and and together with Wilmer and his team on the marketing aspect for the film capacitor. So my degree is an electrical engineer by heart, and then from Purdue University, and I also had some advanced courses on a master's degree in engineers management, mostly for new technologies development. Below is my contact information, and please feel free to contact me anytime for any question, or if I don't have the answer, I will definitely sure pass the information to the product management team in charge of these technologies. So, a simple overview of what the technologies are, just to differentiate both technologies, and they might look outside similar, and it could be confusing for some of you or some of the designers and sales engineers. A C4AQ-M is a DC-Link capacitor. It's a metallized polypropylene. So as a DC-Link capacitor, the main function of this is that it requires, of course, the goal is to have the most higher density as possible, and then it's also require a DC bias operation. So this technology is designed for that. It has to require a DC bias. There's some level of ripple capability, and then the information you can find it on the data sheet of this technology. But it's not recommended is to use this technology as a pure AC filter capacitor or a pure AC signal input on the capacitor. So again, all the technology that we're going to be talking about right now, these two technology are going to be, all of them are ACQ certified. So no question about it. All the part numbers are certified on that. And in the case of the C4AF, it's a different design internally, and the main reason is because it's designed for mostly pure AC signal filtering. So, and then RMS is very compromised. It's very critical to have high RMS. ESR is also critical, and is required, of course, to protect the capacitor for that variation or that sinusoidal or that high harmonic frequency content that you see on applications where you require an AC filter capacitor. Typically handle more current capability than typically EMI suppressor capacitor. Is being designed to work together with an EMI suppressor capacitor to handle the higher portion of the ripple capability on your switching design. So again, it's also ASCQ 200 qualified. So some of the construction is the metallization aspect is critical. The thickness of the dielectric, the metallized polypropylene is also critical. Typically, C4AF is larger than C4AQ in this case, and the idea is just again that AC fundamental is affecting the capacitor had to be more protected for that fundamental. We're gonna start with C4AF. We just launched this one last quarter, and an enhancement. We call it C4AF-T. Maybe there's some confusion in the field, or maybe to avoid any confusion, the main reason it's called C4AT is because it's to differentiate what we have before the C4AF standard. But in reality, it's the same C4AF with some more advancement on live capability and harsh environment capability. You will notice on the data sheet of the capacitor a T on the code here. Before, you will see an A as an apple, but now you see a T as a Thomas, and that's how you differentiate this new technology is a new technology with this upgraded feature. It has a higher reliability in harsh environmental condition. You can also find a 500 VAC voltage extension on this technology. So some of the features I can go through, some of the most important features here, as I mentioned before, the harsh environment condition. You can see here that before we were just rating this capacitor, the A version was rated to only 500 hours. So now it's rated to 1,000 hours. 1,000 hours to apply voltage of 83% of the nominal voltage applied to the capacitor. So that makes it kind of interesting for a situation where you require more heavy-duty solution for harsh environment application. So in the case of maximum voltage 500 volt is also a very good advantage. Also, your some slides is showing that advantages of the 500 VAC volt. And there's also a 600 volt VAC version, and we only provide it by request. However, in the future, in the roadmap, we'll show that 600 VAC voltage as well. Application-wise is automotive, as I say, qualified is energy, all the application in energy, solar, wind, and also storage energy as well, and industrial application. Of course, it could be three-phase and single-phase application, input and output filters with the LC filter level. So to give you an idea, some of the designs, performance, or comparison that we make in our lab and our development of the technology, we tested this capacitor, as I mentioned before, to 85 relative humidity with this condition at the end of the 1,000 hours. So this is a capacitor that is being requested by many customers in the field under those conditions beyond the automotive industry level requirement. So in this case, we did an exercise, benchmarking exercise with some of our top competitors, similar part numbers, close part numbers, or voltage. And then we noticed that the performance of C4AF, and in this case, is much better than the performance than this technology, despite that they are claiming that they are also harsh environment capable. So we notice even beyond minus 10% differentiation, which is basically a key requirement for us to certify this capacitor as an 85 for us. However, we just really noticed that some of those top competitors that from us are in some level at the edge of the performance. So that's how we feel confident that this technology for us, KEMET C4AF, is more robust than many of them. Okay, so the other benefit that I would like to mention is about the 500 VAC voltage capability from 1 microfarad to 50 microfarad solution. So, and this is something that is also being requested from the field, requiring higher voltage capabilities for single phase or three phase. In the case of three phase situation, now you have a capacitor that is capable to be connected in delta situation for application of 500 and 480 and 400, even 400 VAC, with better derating situation. Mostly America and Canada can manage this market, and then 400 VAC, also Europe and Asia. And then again, it's a solid resin technology. So in this case, even with this higher voltage, you can also consider the supplement, the idea of replacing impregnated technology, canister technology on a more PCB-oriented design, improving performance on higher temperature up to 105, and also miniaturization is possible. So this is something that that the 500 VAC will bring also this potential capability for your design. In the case of the C100 VAC line-to-line configuration power line, in this case, the closest chance is at this moment for the 500 VAC solution, excuse me, sorry, is having the configuration in a Y configuration. So that will bring this technology also capable to have a better derating capability compared with the previous technology that it was only 400 VAC. In this case, again, is in the future, again, is if you require 600 VAC delta configuration, please contact your local sales representative, and then we'll be happy to review your projects and happy to provide you the 600 VAC solution at this moment as well, okay? To make a brief comparison level on this technology, these are kind of the top competitors. I mean, you can see also their series. Some of them are, again, are capacitors that are basically kind of matching the technology in our case, and we're getting also matching their technology. Some of the advantages that we noticed, as I just saw before, is the performance on 8585, even that they claim that they are grade 3 or 3B situation. Some of them are at the edge of the performance. So again, we don't compromise. I mean, some of them are, I mean, it's good technology. However, if you want more robust technology, so you can also consider a C4AF from KEMET technology. And again, another consideration is that we noticed that the DVDTs, we are a little better than them. So if that's something that is important for your design, so please consider that we have a better DVDT performance as well as them, and even current capability, ripple current capability. Other than that, I mean, it's again, you have another technology for your design that you are more than happy to select. And then one big advantage of our design is that none of these technologies from the other provider has, and I will show you one of that from the design aspect, is that we have this technology simulated in our KLEM live calculator, in our KEMET KSIM 3.0 platforms in the website. So it's available. You can have access to it directly from the KEMET Web Engineer Center. And then the main topic is that you can also just basically introduce your mission profile depending on the technology that you're requiring, that you're looking for, and you can select the capacitor. And the calculator, based on your mission profile on voltage apply, ambient temperature and humidity, and working condition for that particular profile, the calculator or the KLEM application will give you directly the estimation of hours in life. So, and then this is something that we presented also. We were planning to present it in APEX this year, however, because of the pandemic situation. So we have a webinar recorded about KLEM. You're more than welcome to go into our engineer center and find that webinar where our expert engineer from R&D presented this technology in more deep details. So, however, again, you have access to this technology, and this is something that is easy to design from us when you are selecting the C4AF-T. There's other series there. Another capability of this one is that, like, again, you can adjust. You can see that adjusting the performance on the working condition of your profile, you can see how the life is affected. So in this case, it's a string condition with very high humidity level situation. So you can see that your capacitor, you can also select potentially another capacitor with higher voltage to see if that will also help to perform better in live performance. So this is an example. You can select different values of capacitor, different series of capacitor as well. And then based on the calculation, it will calculate from you and compare the level of the profile, the same profile, mission profile. You can add profile as well. And then you can determine which one is the best approach solution for you, depending on the voltage, the ambient temperature, and the humidity in this case, okay? This is just an example of how compare different values and different voltages on the same profile, mission profile aspect. You can also remove profile. You can also add other technologies as well. And there's other technologies there in this KLEM application. So some of those are the safety capacitor X2 harsh environment that we have, FA62 V054 and FA63 X2 as well, and also the R41T high temperature harsh environment Y2 technology. So coming soon, more series will be added. The 500 volt will be added to this application. So just be always checking out or let us know if there is something there that we can help you also to do some calculation as well. But you can do your own calculation, and this is something really, really nice for your design. Talking about C4AF roadmap situation. So in this case, we see that we just launched again calendar year Q3 the C4AF-T enhancement for this technology up to 1,000 hour temperature humidity bias. This coming year, the goal is to go more miniaturized as possible with extension smaller. Every miniaturization extension will require for us to go smaller in capacitor size. So, and then of course going higher in 85, and then with, in this case, even segmented film technology as well. So, and again, there's the C100 VAC coming soon, and then to the extension of the C4AF. And again, keep us challenging us, and then if you require anything beyond that, what we have right now, and which is fantastic design for fantastic technology for your design, so let us know, and we'll be happy to review your project. Okay. So now passing from the AC world to the DC world, we're talking about C4AQ-M now. So in this case, C4AQ-M, as I mentioned before, is a DC-Link capacitor. The main upgrade versus the C4AQ that you might know from us as well is miniaturization and higher DVDT and new data sheet versus previous C4AQ. You can have a new data sheet. This is a complete new data sheet compared with the previous C4AF, which is the same data sheet. This one has his own data sheet. And you will recognize the difference between the C4AQ and the C4AQ-M is basically the M at this particular code of the part number. So that's how you differentiate the both technology. Application-wise, similar to what we talk about the C4AF, and then of course in this case is we're talking about at the level of the DC-Link aspect of the capacitor here. So capacitance values up to 210, and I'll show you some slides showing you some of the advantages of that. Miniaturization or optimization of space. So to give you an idea versus C4AQ, 28% reduction in volume versus C4AQ before, 29% in PCB surface area. And then in this case, an average of 17 to 15% up to level. So there are some options that you reduce the pitch size of your technology you were using C4AQ in the past. So these are some of the voltage and the capacitance that you reduced that were reduced. On the harsh environment capability, we maintain the best harsh environment capability even beyond AACQ200. So AACQ200, if you remember right now, is still 40, 93 on the case of capacitance temperature and relative humidity. This technology is beyond that. It's 60 to 95 relative humidity and nominal voltage, 1,000 hour. And even the degradation is less than 5% versus 10% compared with the ICQ200. So again, it is a design perfect for automotive, and then even beyond automotive rated level, okay, for harsh environments application. So talking about some cost to competitor level, if you look at some of the top competitor, if we compare the same capacitor value and the same voltage application, we notice that the volume is much better. I mean, in this case, the competitor A, which is one of the top competitors for us, is the volume is 49% and 49% area higher than our part C4AQ-M. But if you notice here, the performance of from 5 kilohertz to 100 kilohertz, even 500 kilohertz for this technology, is just basically matching their same current capability RMS per frequency at 70 Celsius degrees. So again, it's not only related to performance in volume, but it's also related that you are not compromising, in this case, even versus competitor, the performance of the technology on current capability. So this is another example is of the delta T capability of C4AQ-M is up to 30 Celsius degree delta T cell heating internally. The competitors, they typically do to 20 delta T capability. So again, you are optimizing more current capability below 70 Celsius degree and even after 70 Celsius degree. One detail here is just that, again, also, sorry, passing to the next level. Another characterization here is the level of another competitor, for example, competitor B, is the reduction of the pitch dimension from C4AQ-M versus the competitor, one of the top competitors as well. You'll see some of those names later. You can see the level of ESL reduction. It's much way lower, the reduction of ESL. That gives an advantage of extending the frequency range of up to 86 kilohertz level. So that means that your application can go closer to higher frequency, even beyond what you were expecting to use a capacitor, well, for this particular dimension. So higher frequency, lower a smaller miniaturization, but at the same time as well, you are improving the performance on high frequency for if you are using high frequency devices in this case, like for example, MOSFET or IGBT. So to give you an idea of capability of easy to design with in this technology with us, typically this is kind of the process that we always consider to do the calculation of a technology based on your designs. Of course, you had your information of what you need, the capacitor that you need, the DC-Link or the AC filter, and the RMS, the ambient temperature, the duty cycle, what we call the emission profile. Now, and the level of calculation, before you start building your PCB board, we can provide you some easy to design situation for a hotspot and then the calculation of light. So, and the feed values and the curve and everything. So this is where the data sheet that you will have from C4AQ or C4AF, you can also utilize and use and do some regular calculation for that. You can also do the simulation tool like the KLEM. In this case, we're also working on a live calculator for C4AQ-M and other DC-Link technologies. And then I'll show you some example how easy it is. At the end of the day, sample testing, we can provide you even sample with thermocouple internally embedded to a better calculation to match what you see in the calculation, the previous calculation versus your real life application aspect of your design. So for example, another design characteristic, this is, let's use this as an example. So if you are, for example, designing an input filter or output filter or DC-Link capacitor bank for 100 microfarad, and then you want to use a 10 microfarad capacitor, 1300 VDC capability, 70 Celsius degree. And let's assume, for example, 900 VDC operational, 50 kilohertz, 100 kilohertz, 300 kilohertz operational range. So comparing the same solutions available at the market right now from 3 particular competitors, even with C4AQ that we have, you can see the advantages on miniaturization versus the competitor aspect. So you are beyond even higher than 20% improvement and dimension inside of your capacitor. In this case, the volume and not only the volume, but also the PCB area is also improved. So RMS-wise, the capacitor maintain a very good higher mass version. So competitor B looks like he has a higher capacitor current capability versus 13.8. At the end of the day, reality is that also dimension-wise is 32% bigger than our part. So that means you can even probably add 1 more capacitor there or 2 more capacitor with more capability, and then you have an example number 2 here on the right. So example number 2 is just comparing 2 technologies, our technologies, C4AQ-M and C4AQ. So the same performance, 100 microfarad, and then 1300 VDC volt at 70 Celsius degree. Talking about this, and in this case, 10 microfarad, 10 capacitor, they will give you 100 capacitor total, capacity total. So it gives you an application aspect of how much current is enough there to hold it, and then how much current is capable of that. So of course, C4AQ is a little bit larger capacitor. You can see that that it has a larger capability of scoring. However, dimension-wise, if you compare the 2 capacitor, in where you put 10 microfarad C4AQ, you can put 14 capacitor in parallel C4AQ-M. And that will improve not only in the level of capacitance available, but also energy available, but also current capability, better ESL, better performance, and even better performance than in the situation of your Ripple reduction of your design. So again, this is just a rough calculation, but in this case, it just gives you an idea that you have more energy in the same space that you were using before, only 10 capacitors. And then we also have a tool capability for this as well that we're going to be just releasing next quarter for you to do those calculations as well. Again, now let's pass into the level of how to calculate the life of the capacitor, okay? So in this case, C4AQ-M life estimation is based on your emission profile. I make an example here with 3 particular conditions on ripple capability and ambient temperature in this case. So in this case, we're assuming 50%, 30%, and 20% of duty up cycle on those conditions, or 900 volt. And let's change some current here to make some differentiation here. And of course, let's also change some frequency to see the stability of the performance of C4AQ-M under those levels of high frequency. So doing that, entering that information, we can easily calculate the hotspot and life calculation of the capacitor. So every particular line here, it will create a VRMS. I will create, of course, the level of RMS that you have here, enter, and it will create a delta T. So you create a delta T inside of cell heating inside of the capacitor. That cell heating added to the ambient temperature will create the hotspot of the capacitor, and we can calculate the life. Similar to KLEM, we can calculate the life of each condition per your emission profile. So adding those together, we can do the calculation as easy as just pressing a button. I will give you an estimation of life performance of the capacitor. So you can do the same. You can also go to the data sheet and do the calculation by yourself, estimation, and then following the life plot. However, everything on the data sheet is embedded on the calculator. So again, this calculator is still not available, but we are happy to assist you as much as possible on this calculator is being released to the field and the KSIM platform. But again, you can also do this kind of calculation manually, or you have an application software you have, or Excel, to do that calculation. And then some of the advantages there that you can notice is that C4AQ-M and C4AQ now can extend the life up to 200 hours level. Before it was only up to 100 hours, 1,000 hours. So now you can just even way beyond that. And there is a particular point here that is a requirement from more and more from the automotive industry. They require even a certain amount of hours, the capability of capacitor to reach the level of 125 Celsius degree. So of course, there is not only a few 100 hours, but the goal is just to reach that 125 Celsius hour derated voltage. Beyond that, and then I'll show you something on the roadmap for this technology. Okay, so technology-wise, I mentioned before, just summarizing, it's just we perform much better, and on the C4AQ-M perform much better than the technologies, the competitors, our top competitors, on the level of the miniaturization, and also in the level of, at the end of the day, on the level of energy density, all together with even with ESL on some of those values. So again, and then it's also qualified up to maximum 125 Celsius degree for a certain amount of hours. Okay, so keep in mind that again, C4AQ-M is available, and it will be launched this week, this particular week, the 17th. So you're gonna have those parts available in our distribution partners companies. Talking about roadmap situation for DC-Link technology. This is just an overview of what the roadmap. I kind of make it in this way to know mostly by quarters, but mostly by families. C4AQ is a family of our 125 Celsius degree capability. At this moment, 200 hour, 125 Celsius degree, and higher DVDT. I mentioned, probably I missed this one, but C4AQ-M has a higher DVDT than C4AQ, and low ESL and low profile miniaturization. So again, this is now available. C4AQ will be available, and will be available starting from this week. And coming soon, and it's going to be C4AQ-P, which is going to be now 85, 1,000 hours at certain level of rated voltage, 85. But now you can just see the extension of 4,000 hour capability at 125 Celsius degree capability. So again, this is something that is coming soon. We have even some part numbers available. If you are interested to review with us, contact your local sales provider, sales representative. And then coming soon also another series which is more related to harsh environment level, which is 8585 at rated voltage 1,000 volt, which everybody knows this temperature humidity bias robustness situation. And then it's going to be C4AU. It's more extended to not to higher situation of temperature, but also on 8585 1,000 hours. And again, also coming soon, 135 Celsius degree technology, 8585 1,000 hours C4AK, and then with levels 1,000 hours at that level of 135 Celsius degree. This is what is coming very soon. We also have available some part numbers available, engineered samples available if you are interested to test this technology as well. So that concludes the presentation. Hopefully, I believe it took us probably 31 minutes probably, or 33 minutes probably. So and again, thank you very much. And then hopefully you learned something good from our latest technology. And please let us know how can we help you with your design. Okay.
Yeah. Thank you, Hector. Right up, well, you're a couple of minutes over, but that's cool. We initially had set this for 30 minutes. Now, if anybody has any questions, Hector and I will stay on the line for a little bit to answer some questions. So I'll give you a moment to enter some questions here through the Q&A portion of the Zoom session. And while perhaps some questions come through, I want to remind everybody that this is actually our, like I said earlier, our last webinar here for this year. We'll actually be picking up our webinar program on January 18th. We'll pick that up again, and you'll be seeing invites, and that'll be showing up in our engineering center website and our digital properties. And obviously, those of you who have registered to receive emails, you get reminders of that as well. So I see we do have a question that came in. Hector, the first question that came in is what degrades the film capacitor at 125 C? So what's happening at that high temperature that causes the degradation and that sets that upper temperature limit? Is it the constant power that passes through it as well as the temperature? If you're talking, Hector, you're muted.
Sorry for that. Yes, if we're talking about 125 Celsius degree, even a hot spot, let's say, for example, you are in a situation of the 100 Celsius degree ambient, but you put 25 Celsius degree delta T inside of the capacitor because you have some current inside of the capacitor. 125 Celsius degree is the degradation of the plastic polypropylene. So polypropylene, the higher the temperature, the more brittle it start degrading, the faster it start degrading. So it start to make it's not being flexible. So the capacitor start to shrink. So that means you are losing the property of the polypropylene. So getting polypropylene to that level of 125 Celsius degree, 135 Celsius degree is being very challenging for everybody, for all the manufacturers. But yes, it's the plastic that is getting degrading faster than the typical situation for polypropylene. If you can control the temperature, polypropylene can last longer life. That means that's why some of the designers in the automotive, they use cooling system, or they use some specific cooling plate to try to maintain that level of temperature to release that heat. It could be the current, it could be creating the cell heating, or it could be even the ambient by itself. It will degrade the plastic.
Okay. Thanks, Hector. The next question is about, I think somebody may have found a question in one of the slides. On the last page, the picture of C4AQ-M shows 105 and not 125. Is that an error? Just maybe bring some clarity to that.
No, that's a good question. Let me let me see, show you here, probably it's on the first page. When we qualify the technology, we qualified that you can see that it's 105 Celsius degree. It's capable to reach 125 Celsius degree. But when we qualified the technology, we had to go follow IAC specification for the capacitor. In this case, for a power film box capacitor DC-Link. So if we want to qualify the technology, and you can see the life of the plug of the capacitor. Let me find the plug of the capacitor here. So we need to meet certain levels of life and performance on 105, and that is why we meet IAC. However, that doesn't mean that the capacitor cannot reach 125 as long as you don't exceed certain levels of hour. Okay, so that is what it's going to call is maximum 125 Celsius degree, but the qualification, the complete qualification of the endurance and the performance of the capacitor is basically following IAC standard for film capacitor, and that is why we qualify for 105. Did that answer your question?
Okay. And then the last question I have thus far is about C4AF and KLEM. Is C4AF there? You know, are the things that you described, are they available in KLEM?
It's available in KLEM, yes. The only thing that is missing in KLEM for C4AF, in this case, I mean, you can see it's called C4AF-T. We called it C4AF-T before. However, we kind of, to avoid the confusion, is still the C4AF family. The only thing that is missing in C4AF there in KLEM is the 500 volt VAC portfolio that we have from 1 microfarad to 50 microfarad. Okay. That's the only thing missing. But you can just go to the KLEM website that is linked here, or the KEMET KSIM platform 3.0, and then you see film lifetime, and that is KLEM here. I don't know, you guys can see my mouse or not, or my.
Yeah, we can.
Okay, so that is where you can find, and now you can select the technology here. In this case, the AC filtering technology, C4AF, but you also have X2, Y2 technology, EMI suppression there as well, that are designed for harsh environment application.
Okay.
It's available.
So I see we don't have any more questions. So just one last thing before we adjourn. This presentation will be sent out as part of the follow-up email. And also at the end of the presentation, we have a bit of a survey for you to fill out, so that we may improve these sessions, these webinars, and the information in our delivery. So we'll appreciate if you can take a few moments to fill that out. And with that, I'd like to thank everybody for attending, and we'll see you again next year when we pick up our webinar program. So thank you very much, and thank you, Hector.
Thank you, Wilmer. Thank you very much, and have a good day, good night, and good afternoon to all of you. Thank you so much for your time, okay?